Chapter 6 review, page 409. For the first two problems, solving by graphing, I'm going to do problem 6 before number 4 because number 4 is a little bit awkward. So the first thing I want to do is graph y equals 2x plus 3. To do this, I set x equal to 0 and I get the intercept. Using then the slope of 2, I count up 2 over 1, and I can do the opposite direction as well. Then by making more dots, I connect the dots, and there is the line y equals 2x plus 3. The second equation, y equals 1/3 x minus 2. Again, when x is 0, I get the y-intercept, negative 2. The slope is 1/3, so I count up 1, right 3. And going up 1, right 3 again, and then going the opposite direction, I connect those dots. Notice that the two dots intersect at the coordinate -3, -3. So the solution to that system is -3, -3. If you plug those values in to both of those expressions, you will see you get true statements. Now for number 4, the first expression, y equals x minus 3, I can plot when x is 0, y is -3, and then I have a slope of 1, so up 1 over 1. The second equation, y equals 3x plus 13, is where it doesn't fit onto the graph. So I have to keep subtracting the points until I get the first coordinate, which is -3, 4 will fit on the graph. The next point from that is down 3 over 1 to the left, and there's that graph. As you can see, it did not fit on the equation, so it did not fit on there. Sorry for that. Going on to the next set of problems then. We have solved each system by substitution. If a no solution or an infinite many solutions, explain why. So for number 12, I have to use substitution. So for the first expression, notice that y is equal to y. I highlighted in blue. So I'm going to substitute 2x minus 1 in for y. So that gives me for the second expression 2x plus 2 times 2x minus 1, again, that's where I substituted, is equal to 22. Following order of operations and procedures, I distribute, I combine like terms, and then I add 2 to both sides, and that will give me 6x is equal to 24, which tells me x is equal to 4. Now that I have x is equal to 4, I can bring down my first expression, which is already solved for y. And now I substitute in for x. So that gives me y is equal to 2 times 4 minus 1, which then gives me y is equal to 7. So the solution to the system by substitution is going to be 4, 7. The next equation, we don't have it solved for y. So what I have to do for that first expression of 2x plus y is equal to -12, I'm going to solve that one for y, and the only reason I solve for y is because it has the easiest, lowest coefficient, which is 1. So I subtract 2x from both sides, and from that first expression I get the following equivalent statement, y equals -2x minus 12. Since I have the first expression solved, I bring down the second expression. Here again, I will have y from the previous statement is the same y from the other, so I substitute. So I get -4x minus 2 times the quantity of -2x minus 12. Again, that's where I substitute is equal to 30. I wanted to do the same procedures before, distribute the -2, and I will get the plus 4x plus 24. And notice here I would combine like terms, and -4x plus 4x is 0. They cancel out, giving me 24 is equal to 30, which is a false statement, which means no solution, which basically tells me they're parallel lines and they do not intersect. So in order to have a no solution, you get a false statement and they are parallel lines. For number 16, I'm fortunate enough that the first equation is already solved for y. So I don't have to solve one of the equations because the first equation is already solved. So I want to substitute x minus 7 in for y. So here I get 3x minus 3 times, which y is now x minus 7 is equal to 21. Again, distributing, I get 3x minus 3x plus 21 is equal to 21. Combining like terms, the 3x cancels out. I get the statement 21 is equal to 21, which is always a true statement. So it has infinitely many solutions because they are the same line. If you solve the second equation for slope-intercept form, you will find that it is equal to y equals x minus 7. Going on to the elimination method. For the elimination method, we have to actually eliminate one of the variables. In the first expression, I want to eliminate y. So notice I underlined the 4 and 3. Now what I have to do is multiply that entire first equation by 3. So 3 times 5 is 15, 3 times 4 is 12y, and 3 times negative 83 is negative 249. For the second expression, I multiply by the 4, which will give me 12x minus 12y is equal to negative 48. Here, notice that what I did in accomplishing that was I eliminated the y variable, because when I add positive 12y and negative 12y, I get 0. And then I have adding 15x and 12x is 27x, and adding negative 249 and negative 48 is negative 297. Notice that throughout the entire expression, I always refer to adding. Even though I do have negative numbers, I refer to adding the opposite. So 27x divided by 27 divided by 27, that tells me x is equal to negative 11. Now that I have x is negative 11, I bring down one of the original expressions. Here, x is the same value, so x is equal to negative 11. I substitute. I have 3 times negative 11 minus 3y is equal to negative 12. I then use order of operations and simplify. So what happens is I distribute the 3, subtract the 33, negative 3y is equal to 21, so y is equal to negative 7. So the solution is negative 11, negative 7. Now for number 23, I don't have enough room to the right. So what I can do, though, is the first expression I can leave alone, because the least common multiple of 4 and negative 2 is the same. So I leave the first expression alone, and the second equation, I distribute the 2 to each. So 2 times negative 2 is negative 4, 2 times 6 is 12, and 2 times 9 is 18. Notice that I have my x's, y's, equals, and constants lined up. And what I wanted to accomplish was I wanted the x's to cancel out. 4 and negative 4 is 0. Now for the y's, 1y plus 12y is 13y, and 21 plus 18 is 39. Divide both sides by 13, I get y is equal to 3. Since I have the first expression is the easier one, I can bring that one back down, and as I've done multiple times, is I substitute in the y value. With simplifying that, I get 4x is equal to 18, and then divide both sides by 4, I get x is equal to 9 halves. It is not more difficult, I just have a fraction as an answer, so the solution is 9 halves and 3. Both of those are going to have just one solution. I didn't have a no solution because there's no false. I didn't have identities because there were no true statements. I left with a variable was equal to. Now 26 and 31 are solving inequalities by graphing. The first part of this is then graphing y is greater than x plus 4. From the previous section, we have our y-intercept is 4, our slope is 1, so there is the line y equals x plus 4. However, I want to be greater than, so therefore I must be above. I shaded in a little bit better. So for the other expression, I have y is less than 2x minus 1, so my intercept is negative 1, and I have the slope of 2. Notice that I have open face circles, and I have a dash line because I'm not including those points. So I want to shade below, and filling that in, I have just those following regions. 31 is a little bit more complicated, but still manageable. So for the first expression, I have 4x plus 4 is greater than 2y. It's not in any particular form, so I divided everything by 2. So that gives me 2x plus 2 is greater than y. However, reading this from left to right, I have the statement y is less than 2x plus 2. So that's slope-intercept form. I have the dotted line of that expression. Since I'm reading it left to right, it says y is less, so I have to shade below. And that is that expression. Now for the second expression, I have 3x minus 4y, that's in slope-intercept. So when x is away, I get y is less than or equal to negative 1/4. Notice because I divided by a negative, I had to flip the sign. So I have to be cautious of that negative symbol, or less than symbol. And then when y goes away, I get x is 1/3. That is the following graph using slope-intercept form, poorly established because the functions are there. Now going back to y is less than, because I'm dealing with y is less than, I shade below. I shade in that region, and then you can see the double shaded region. That is graphing. That is the complete review.